Good morning, ladies and gentlemen. As our global population increases and industrialization increases, so does the plastic consumption. Just keep aside the world statistics. Australia alone produces nearly 5 million tons of plastic waste annually. And do you know, only 12% of them are recycled. That means majority of them are being landfilled or ending up in oceans. And when it comes to recycling, you must be imagining in recycling facilities, many high-tech machineries must be doing in tandem to produce cleaner products. But in reality, there are hundreds of people like this manually sorting plastics. To tackle this waste recycling problem, the Australian government has come up with a monumental challenge. So they are going to have 80% recovery rate by 2030. But do you believe we can achieve that 80% recovery rate by going with this manual sorting? So this is where our project comes into play. So we have developed an AI-enabled robotic system where you can sort and identify plastic, different plastic types, and sort them accordingly. So what we have done, we have utilized a deep learning algorithm to teach a computer program to identify different plastic types, PET, HDP, likewise. And you must be wondering, there are already AI-enabled robotics technologies, robots there. So what is the difference? So that is the catch. So we have developed our unique Australian data set. That means we have created a comprehensive 55 classes, which that means we have identified all the plastic types. So if you go to a Coles, Woolworths, any other local supermarket, whatever you buy from a local supermarket, we can identify those plastic items through our system. So, and on the other hand, so we have increased this, we need to increase the efficiency of the system as well. So what are our next steps? So I'm happy to introduce to you that we have finally produced Australia's first AI-enabled robotic system. Now we have developed our prototype system. Now it is Australia's first one, and I have created over 400,000 data points, collecting data points on the plastic recycling facilities. Now we have created the prototype. Now, what are our next steps? Now we have created our first prototype. Now we need to increase our efficiency. How we are going to increase our efficiency? So now we are developing a novel algorithm to sort and pick plastic properly. So we just not want to pick plastic. We just not want to sort them, but we want to sort them efficiently. And also, we are going to incorporate a hyperspectral camera with our system. So apart from using RGB camera, so we will be using a hyperspectral camera so that we can sort plastic more efficiently. Thank you very much.
Thanks, Hasala. Okay, there is a question from the audience. How many different plastic types are there?
So basically, we have PET, PP, HDP. So these are the main 3 types.
Yeah.
But if you go to deep, there are so many others because we have to differentiate from its color, its type, its product, its brand. So we are going to incorporate all of this in our system.
The second question is: are you now you've got a pilot done? What's the next stage?
Yeah. So our pilot is working now properly. It can identify all types of plastics, but we need to improve it further. So what are our next step? We are going to incorporate an algorithm. So the existing robots we have, they are not using such kind of algorithm. So we are going to improve the number of pickings per minute. So the commercial ones we have right now, they are up to 50 or 60, but we are going to increase up to 70, so 80, so that we can have a maximum recovery rate.
Fantastic. Thank you. Please join me in thanking Hasala.